question 4. So to start with, we've got to show that angle COD equals 0.906 radians. So first things first, we're told that what are we told? We're told that we have a radius of 8. So we've got a radius of 8, 8 and 8 here. We're also told that these are isosceles triangles. These are isosceles triangle. This is an isosceles triangle here. So on the back of that, we can see that this is also a radius. Okay, and this is also a radius. It's an isosceles triangle, so both these sides are 8. So our isosceles triangle comprises sides 8, 7 and 8. Now we're given the cosine rule. This is it rearranged to work out the angle when we know all the sides, little a, little b, little c. Now the angle is capital A, so I'm choosing to make this angle, our required angle, capital A. So our 7 is little a, and these two can be b and c respectively. So cosine the angle we need to work out equals b squared plus c squared minus a squared. So 8 squared plus 8 squared minus 7 squared, all over 2 times b times c, 2 times 8 times 8. So popping this right hand side into my calculator, I get 79 over 128. So cosine A equals that. So inversing cosine both sides, I get 0.9056 dot dot dot, which equals 0.906. Remember to have your calculator in radians mode as you do that inverse cosine. Now we're being asked to work out the perimeter of this shape. Well, a lot of it we know already. We know the 7, the 8 and the 8. The only thing we're missing is the length of the arc AD, which is the same as the length of the arc BC. Now that's easy enough. That length of that arc is going to be r theta, so 8 times whatever this angle is here. So what is this angle here? Well, we know it's the same as this angle here, so I'm going to call them both x. We know angles on a straight line add up to 180 degrees, or while working in radians, add up to pi. So pi less the angle A that we worked out in part A, and then split that over the two x's, so dividing by 2 we can see that angle x is 1.1179 in radians. So back to the length of the arc AD, which is r theta, that is 8 times the angle we just worked out, which is 1.1179, giving us the length of the arc being 8.9438, and as I said, that's also the length of that arc here. So our total length all the way around the shape is 8.9438, add 7, add 8.9438, add 8, add 8, giving us 40.887, which rounds to 40.9. Okay, so that's part B. Now part C, we're being asked to work out the area of our shape. Well, we've got various bits and bobs going on here. We've got two sectors, so sector OAD and sector OCB. They're the same. They have the same area. That's half r squared theta, and half times r squared times our angle here, which we've worked out to be 1.1179 previously. So we know that we've got a couple of areas of sectors of 35.77. Now we also need the area of this triangle here. Area of a triangle is half AB sin C. So half times 8 times 8 times the angle here, which is 0.906, so sin 0.906. So half times 8 times 8 times sin 0.906 gives us the area of the triangle being 25.19. So add together the area of the two sectors together with the area of the triangle, and we get 96.7 to 3 significant figures.